Hello ma'am, this is Jones. I'm going to do the sixth lab experiment of a compiler lab. In this lab experiment, we are supposed to create simulate the working of an assembler. Okay, let's go to the coding part. Okay, before going to the coding part, let me explain. This thing has the three data structures: the op table, the symbol table, okay, and then the intermediate code is generated. Okay, then we have those other things, data structures. Okay, so let's go for the coding part. So we have to create the data structures also. Okay, so first we are creating the buffers. Okay, file readers and buffer readers and writers for reading and writing from the assemblers or the op table, intermediate code, and so on. Okay, so first this is our input file. The assembler.txt is our input file. This is where we give the input code. Okay, the octave contains all the opcodes. Okay, for LDA it's 007. Okay, intermediate code, that is during fast 1 pass 2 the intermediate code is generated. So the intermediate code is obtained here. Okay, a symbol table contains all the variables like names and so on. Okay, that is it. So that's it, and our output we obtained over here. So here from these 4 files we are reading the input, and intermediate code has to be generated according to the input, so that is writing. Okay, symbol table is also has to be constantly updated, so that is also writing. Output also has to be updated, hence that is also writing. Okay, so whenever this thing like buffer reader 2 is for the op table. Okay, whenever our op table is not null, we go inside. Till our op table is not null, we go inside, and suppose if the op table is not is null, we are assigning the value of x to op table. Okay, and if it's not null, we are concatenating the space with x. Okay, so whatever the value we have is just concatenated to this thing op table. Okay, next one is the this thing this is where the code is going to be generated. Okay, so we have the location counter. Actually this is for holding the address. Okay, and the length and start are also there's variables it will be used. Okay, so let's go on. So we are splitting everything according to the space. Okay, and storing it in the words array, and we are setting another counter as equal to 0, and we are repeating it till our input is ending. Okay, so if it contains start, okay, then we have to start. Okay, and start and assign the value of n equal to I, and increment the value of I. Okay, this has to be done repeatedly. Okay, and the length of the word fails to be greater than I. Okay, next this is done. So afterwards what happens if words dot length greater than n, so if the words the array's length is greater than n, okay, and the location counter we are increasing the location counter. Okay, size, adding more. Okay, and then we are printing the location counter. Okay, because to print the address where it is present. Okay, else we are setting the location counter as 0. Okay, and then okay, that concludes this part. Okay, now we are going to assign start equal to LC. Okay, then bw.write line. Okay, so we are going to bw.write is our this thing the buffer table to write in the symbol table. Okay, so if I encounter any variable, we are going to be writing it in the symbol table. Okay, and so on. So let's go to the next part, that is a new line just adds an extra line. Okay, that's nothing to do. And next we have we create another opcode and required statements. Okay, so here what happens is we have I less than word, we are incrementing till the length of the array is greater than I. Okay, and then we are having an op table which contains word of I. Okay, if it contains word of I, okay, that is for op tables contain the code, opcode for that one. Okay, then we are splitting the op tab, okay, and storing it in op string. Okay, for op string dot length we are iterating over there. Okay, so we are writing, this is our output. Okay, so buffer dot write, here we are writing, that is the location counter, the opcode, the words, and the opcode plus words. Okay, so that's what is written. So location code, the opcode that is obtained over here, that is obtained from here, the words, that is the name of the like alpha, beta, whatever is written, and here the opcode plus word, the sum is written. Okay, and location counter, if we encounter like if we encounter anything, we have, because it's a word, right, so we have to increment it by 3. Okay, so that's what is done here. Here similarly, if you encounter a word, location counter hash should be added with +3. if it's a byte, +1. if it's a reserved word, the size of the word into 3. Okay, whatever the size is mentioned into 3. if it's a reserved byte, whatever the size is mentioned, it has to just be added, because it's byte contains only 1 byte, so into 1, so that has to be shown. So like, yeah, just has to be added. Next, the length of the file can be found by the starting address, location counter, minus the final address. Okay, and we are just writing everything. Now if symbol table is null, we are updating the symbol table now. Okay, and if symbol table the values are not there, we are just concatenating the value into the symbol table. Okay, and then what happens is this part. Okay, what happens is here is also we are updating the symbol table. Okay, so we are using a loop, so we are just assigning various things, and we are splitting the contents of the symbol table. Okay, the symbol table, the length is lesser than j or something, we are iterating over till that. Okay, equals word, if the symbol table equals any words, okay, then the symbol we are inserting it into an array. Okay, like symbol, and we are replacing everything. Okay, so this part is used to create the final record. Okay, the final output of the assembler. So here, yeah, start, line contains start, we are writing it in a header. Okay, then the word of 0 and the word of 2, that is the name. Usually in this address the name of the file will be present. Okay, and the length, total length is calculated there previously. Okay, so, and we are moving to the next line. Next, after that, text, all the object code generated, right, that will be here. Okay, in the word of 0, and this is for the thing, right, we have to add every text field and divide it by the size divided by 2. So here only one field is there, so after dividing it by 2, the remaining will be 3. Okay, so one will be a 6 byte. Okay, after dividing it will be 3, so that has to be included here. And we are moving to the next line. So finally the end record. Okay, the end record should be 0, 0. Since the end of the file is a 4 byte, we have to concatenate like append 2 zeros in front of it. Okay, so that's the working one. Now let me show you after executing the code. Okay, let me show you the output. First let me show you the assembler. See, this is our input. Okay, so copy, this is the name of the program, the alpha, beta, and gamma, the 3 symbols. Okay, and reserve word, reserve byte. Okay, everything is good. Okay, so next we'll go to the optab. Yeah, optab contains the thing like STA for the output for STS23 and LDA00. Okay, and then finally yeah, let me show the symbol table also. Symbol table contains the variable and its address. Okay, that's the symbol table, and this is the structure of the intermediate code. Okay, so the intermediate code contains the copy. Okay, that is the name, and then the address. Okay, then the alpha, beta, gamma, whatever the variable we have, like this this is what it looks in the memory. Okay, this is the respective opcode, and LDA, this is SDA. Okay, output, and this is this thing, variables. Now, so our final output is this one. So header, name of the file, and the starting address, size of the file. Okay, starting address 6 byte, so divide by 2, 3, 6 byte divided by 3. Okay, these are the texts. This is the end record. Okay, that's the simulation of assembler one. Thank you.